All right, looks like we're ready to make the first pass at coding this up and making sure all the connections work. And then obviously we'll get a simple version just to check everything. And then we'll do some refinements later. So ready to plug this up to the computer. You see the little lights, so we have power coming to the microcontroller, and it should be connected to all of our buttons and the joystick. So let's jump over to the laptop and get this coded up to see if all the connections were made correctly. Okay, ready to start coding this up. And I did go ahead and set up the folder where the documentation is going to be generated to and put those links in all the web pages. And another useful thing about documentation that we mentioned the other day is this project might stretch on for a little while. There might be some gaps. For example, the PCB, at the very minimum, we're going to have to order custom PCBs, and which will cause a delay waiting on things to come from a factory. Possibly similar situation other times with a case and stuff. So we might have a couple delays, which means other things are going to happen along the way. If we were sitting down and doing it all in one day, it's going to be fresh on the mind. But if it stretches out and there's like a couple month gap between working on parts, it might not be so fresh on our mind. So having the documentation, working on the documentation along the way, we have references to all this stuff. Because now for coding up, starting to code up our microcontroller, we have the pinout diagram and our wiring schematic showing how we connected to that pinout diagram ready to go. So even if there was like a month delay between that last step and this one, we would have the stuff right here ready to go, reference for ourselves, not just for somebody else later on. But to code this up, we're in an Arduino, so we can use the pin numbers. That's the ones in purple or green here. Purple for the digital in and out, digital read and write, and along with, and then, also analog write, which is pulse width modulation on several pins. We can do analog writes on the pins that have this little squiggle in the line. That's pulse width modulation. Digital read and write on the purple, and analog read on the green. And you'll see the purple are all integers. And on the board itself, the dev board, like pin D4 here, digital pin 4 says D4 on the board, and the pin number is just 4. So we can just store those as integers, and the analog ones also, so A3 and A4, it will recognize those as an integer. When it compiles, it actually uses this number over here in gray, but we don't want to type the number in gray into our code. We want to use the purple or the green numbers in our code, which are just integers. And then we can come down here to this, zoom in a little where we can see it better. Whoops. Sorry, the PDF navigating around by clicking the middle mouse button and dragging is exactly the opposite of the software used to put this together, which always confuses me, and I get confused when I go back and forth. But we can see the yellow button connects to pin D4, so we can just store that to an integer 4. So we don't have to type the D, but we do have to type the A. So we can type just 4, 5, 6, and 7 as integers. Then A3 and A4 will also be integers to set up our pins. So let's go over here and start coding that up. So over in the Arduino IDE, make this a little bigger. So our yellow button, we'll start with testing the buttons. So an integer, I'll call it yellow button. Make it easy to remember what it is. That's going to be the integer number 4. And we're in the C family of languages, so it is strictly type. We have to say what type of thing we have. And then we need the end of instruction character at the end of every line, along with the curly braces when we do blocks. We'll get to that very shortly. And for our documentation, which I should mention, there's more than one sort of encoding scheme we can put in the comments that Doxygen will recognize. And I learned JavaDoc long before I learned Doxygen. So I tend to use basically JavaDoc notation for Doxygen as well. And it does recognize it. And if we have so this is how we set up comment for methods. And if we have a single line, like such as a variable we want to store the documentation for, we can do that right at the end of the line, just with 3 slashes and then the less than character, and then we'll type some note about that. So the pin reference to the yellow action button control. So now that description will be put right into that website documentation about the yellow button, generated right from the comments. It's very useful. So once we have, so I don't need regular comments, I've got the better Doxygen comments here. So once we have the variables set up, I'm just going to do one for the video, and then I'll come back and do the other ones that are going to be exactly the same, that we don't waste a lot of time. We have 2 methods in a microcontroller. If you haven't seen this before, there's a setup method. This runs one time at the very beginning just to initialize everything, and then a loop method, and the loop just happens over and over again. So setup happens one time, then loop happens until we disconnect the power from the device. So for setup for a button, well, we can just we have this built-in method it's called pin mode. And how do we want that? How do we want to set that pin? So yellow button is a variable to refer to pin number 4, digital pin 4, and then that can either be an input or an output. In this case, we want the signal from a button, so we're going to set it to an input. So now it knows anytime we type yellow button in the code, that is an input. In particular, it's digital pin. We're going to read the signal coming into digital pin number 4. And then might as well just print this to the serial monitor for the testing. We're eventually going to go to the serial port anyway, so we might as well set that up to begin with. So serial.begin. And then what is our baud rate? The generic fallback's 9600. Probably going to set it to something much faster than that before long, but I'm just going to start with 9600 and then we'll increase that speed at a point later. So at this point, we have our digital pin 4 saved to a more useful name and set as an input, and the serial communication has been initialized at a rather slow rate. We'll increase that later. And so that is going to, if we say print, it's going to send something down the USB cable, which we can just monitor here for this point, just see that the text coming back. But then later, that is also what we will send what's coming down the serial port to another script somewhere in order, or have another script monitor the serial port. So anything we send down print from here are scripts running on the, well, in my case, on my PC over here, will detect the words or whatever protocol encoding scheme we send down that line, words and numbers. It will pick it up and then we'll use that. But for right now, we'll just print it out to make sure all the connections are working. So now we just need to read what's on that pin, which is going to be a 1 or a 0, depending on if there's a voltage there or not. So I'm just going to, for now, I'm just going to print that out. So serial.println, and what I'm going to do is, well, I'm going to split that up. First off, I'm going to read the pin. So it's a 0 or 1 coming back, so I'll store that in a variable called y, and that is going to be digital read, and we want to read this pin on yellow button, digital read the yellow button, put that in Y, then serial.print. We'll print out the words yellow button. Serial.print. And notice I'm not using print line. That way I can just kind of concatenate stuff together. Serial.print the actual value there. Yellow button. And then I'll do a serial.print line to get a line break. Actually, I'll do two serial.print lines. Get a couple line breaks, and that way things are somewhat readable. I'm going to add some white space down here, make this more, that way the words are easier to work with, more convenient to work with the words in the middle. And I'm going to throw a comment on the closing curly brace so I don't lose track of that. So in the loop method, might as well put one up here as well in setup method. So that's basically what we need to do to check the buttons right now. Just read the value on that button, then print out what that value is just to make sure we're getting something from all of those. So I'm going to pause the video and do that same thing, actually a whole bunch of copy and paste for the other three buttons. So before I copy and paste, I should probably make sure I'm copying and pasting the right thing. That way I don't have to make a whole lot of changes. So we're ready to upload this. So we have a couple buttons here. So we have a compile button and an upload button. And if we just hit the upload button, it will compile and then upload. And I often use the keyboard shortcut for that, which under the sketch option in the menu, we can see to compile it, we can push Control R, or to upload, we can hit Control U, and if we just upload it, it will compile and then upload. So it'll run through the compiler either way. I usually just hit Control U to check it. But we want to make sure it's going to upload to the right board. I can see down here in the status bar right now, it's set to Teensy LCs, so apparently I was using a different microcontroller last time I was on my last project, so I need to switch that to an Arduino Nano. So under Tools, there's an option for the board. So if we come over to Arduino boards, we're going to an Arduino Nano, which Nano has an extra option. We want to make sure we're set to the correct yeah, so I think everything's good there. Oh, this is the one I need to check. The processor. So on these particular boards, Nano, there are different versions of Nanos. So I have the Atmega 328 with the old bootloader on this current board that's hooked up. So you just want to make sure you have the right board hooked up, and if it's the wrong processor, just won't do anything. It'll say it uploaded, but the bootloader won't, on the chip, won't recognize it. So the Nanos I have the old bootloader, so you need to check that, set it to the right board, and then make sure you're set to the right serial port, which this does not have. I'm not sure which serial port that is, 3, 4, or 6. It's probably 6, and then 3 or 4 are the built-in lines, but let's check just to make sure. So to do that, we can go over to Device Manager. So I'm on a Windows machine, so I just opened the regular Device Manager, which was under, I just went to the Start menu and searched for Device Manager, popped right up. But however you get to it, I had to pause the video because the screen recorder that I'm using puts the record button right on top of the Start menu. So I have to, I can't hit the Start menu while the full screen is being recorded. But in Device Manager, we can come down to our ports. So under ports, we have several different ones. So COM3 and 4, oh, those are Bluetooth links, and USB serial on COM6, So I think COM6 is, well, it's not Bluetooth, so that must be the microcontroller. Check down here. So it's plugged up through the USB port, but there's not really anything under USB port. You want to make sure under USB, you want to make sure you look under ports and then the COM, because this will also need this when we get to our other scripts, because, well, if this Nano is connected to COM6, then that's the communication port we want our other scripts listening to. So now that we know that, we can come over here and set the port to COM6. And down here in the status bar, we can see Arduino Nano on COM6. So I'm ready to upload this, but I'm going to do video where I can switch to regular video to do the uploading, and be back in just a second. And then if everything works, then we'll be ready to copy and paste and do the other buttons and slight variants for the joystick.